Every single video or a tutorial that is made should probably start with a promise. And the promise of this tutorial and series for Wolfram Mathematica is that you will become world-class proficient Mathematica user who will be able to simulate anything, calculate anything, and overall be incredibly comfortable with the software suite. Let's start. This is lecture 1 and we'll go over the basics. We'll build on top of simpler things first, and then we will approach more complex things as we go. How do we divide in Mathematica? It's very simple. You enter a number / divided by 2, and as a result you get 50. If you want to delete the output, which is out 1 to 4, which corresponds to input 1 to 4, you just press on that bracket on the right, the smaller one, and then you press delete. Now if you want to delete the whole thing, if you wanted to delete the whole thing, all you have to do is to press on that outer bracket, press on it, and then press delete. And this is it. Now let's go over how does Mathematica calculate things. And Mathematica is an exact software, meaning when you calculate something it does not give you approximate numbers. 1/3 will not give you 0.3 recurrent. That will give you 1/3 as a fraction. And if you wanted to get exact numbers, for instance for 718/3, you need to use the n function, which is numerical. So to get numerical representation of this 718 divided by 3, you need to wrap it in this n function, which starts bracket, then ends bracket, and just inside of it you need to add your expression, and that gives you the exact number. Another thing this function can do is that it can approximate or round things to certain number of significant digits. That is, you can enter 5 in here and it rounded it to 1, 2, 3, 4 and 5 significant digits, just like you see here. Regarding the freeform input now, freeform input, it's a similar thing, but instead of actually specifying what you want to do, you just write it as text. It will become more apparent in later examples in this video. Now let's move towards variables. Mathematica has variables and they work just like variables work in usual mathematics. They can be some sort of number, and in this case our number is 5, and we just say a equals 5, and now a is 5. And the reason it outputs 5 is that this is the default behavior of Mathematica, to output numbers like that. If you want to prevent that, you add a semicolon at the end, press Shift Enter, and it's not visible anymore. And now if you want to use it, you can just press A, Shift Enter, and as you see it corresponds to a value of 5. And let's say we want to multiply that variable with 3, and then we want to add a unit to it, in which case it becomes 16, because 3 times 5 plus 1 is 16. Now what if I want that variable to not have that value anymore? That is, so it's not 5 anymore. You can just say clear A, and the a does not have the value of 5 anymore, it's just a now. Now let's try expanding parentheses. So cross multiplication, right? Let's say I have a simple pair of parentheses factored out quadratic of some sort, and now you want to cross multiply it. You just say expand. You have a bracket, and then inside of it you just put your function, your pair practically, a plus 5, a plus 9, and just expands it. Let's move towards linear equations and how do we solve linear equations. The way we solve linear equations is very simple. You just start with solve function. Inside of it you put 2x minus 1 equals to 0, and the equals has to have two equal signs because a single equal sign would assign, right? So two equal signs instead of one. Then you put a comma, and then you need to input the variable in terms of which you're solving. In our case it's x. If your linear equation was expressed in terms of y, that is 2y minus 1 equals 0, in that case you would have to change this to y as well. There is an alternative to unsolve, which gives us numerical approximates, right? And it works the same way, you use it the same way, but instead of using that solve name for the function, you add that capital N in the front of it. And this gives us the approximate 0.5. Now we can solve these kind of equations with free input form as well, and all you have to do is you have to press equal sign, right? Press equal sign, then type solve, then type your equation, for example 5x minus 10 equals 0. You should notice it, right? I didn't actually use a double equal sign as we did before. I just used a single equal sign, and it solved it regardless. And this is the point of free-form input. You can input it in free form. That is, you don't really have to write all these equations, but the cost is you lose the control. Okay, regarding the systems of equations, how would I solve systems of equations if I had one? For instance, we have two equations. To specify two equations or systems of equations, you first use solve, then you add curly braces, then you add your equation, for instance 2x minus 7 equals 0. Don't forget that double equal sign. Then you have a second equation, which is 3x minus 2 y equals 0. And the way we separate these two equations is that we have this comma in between them, right? Just like that. And now we need to specify in terms of what do we solve it. And we solve it in terms of x and y, right? Because we need both x and y. And that's it, that gives us an answer. X is 7 over 2, y is 21 over 4. Now, how about we solve quadratic equation, right? How about we just get that quadratic equation? Bx plus c and we solve it in terms of x. X squared. Oh yeah, we need to make it equal to 0. And that's it. This is the infamous quadratic equation. We just calculated it. Minus b squared, 4ac, and 2a. Two solutions with plus and minus. Now let's move towards plotting things. Let's plot a simple linear equation. And in order to plot things, you just need to use this plot function, which starts with a capital P, plot, square brackets. Inside of it, you specify the equation you want to plot. For instance, 2x minus 7 without equals to 0, yeah, just like that. And after the equation, you need to specify the range on which we will plot it. And let's plot it from -10 to 10. As you see, we plotted it from x -10 to x 10. We press Shift Enter, and we get our linear function, just like that. If you want to copy this entire graph, you can just right click on it, and here you have all kinds of options. For example, copy graphic, and then you can paste it into Google Docs or something if you want to. Okay, now let's plot something a little more complex. Something like sine x divided by x, and we'll plot it from x, and we want to plot it from -pi to pi. And how do we enter pi in Wolfram Alpha? Because I don't see it on my keyboard, right? We don't have it on the keyboard. And in order to do that, you have to press on the escape button, or ESC button, at the top left corner of your keyboard. And then you need to enter pi, and you'll get the pi, as you see. If you wanted alpha, it would work just as well. So pi, you get the pi, and we start from -pi, and the same thing. Escape button, pi, and we go from -pi to pi. Let's plot it, and we get it. That's a beautiful graph. Now, if we wanted to, we could actually plot it with free-form input as well, in which case it would be sine x divided by x, and as a result we would get this. As you can see, it picked the range of values for the function itself, and as a result we got the graphed function. And we did not need to specify all these equations. All we needed to do is press equal sign, then say plot, and then our equation. Now, if we wanted to plot something in 3D, for instance, we had a sine that took x multiplied by y as input, as an argument, all we have to do is to use the same plot function, but we need to add 3D in front of it. Then we need to say sine x multiplied by y. This is our function which we want to plot. And then we need to specify the ranges. For instance, -10 to 10 is the first range. And for y, we will have a range from -10 to 10 as well. Okay, this is a little too crazy. Let's just reduce it to -3 and 3. and y to -5 and 5. And this is it. We get this beautiful graph. It's a beautiful 3D graph of this function sine x multiplied by y. Now, you could have plotted the whole thing with freeform notation as well. You just say plot sine x multiplied by y, shift enter, you just wait a bit, and it gives you it. That's it. Now, regarding values or sequences of numbers, you can easily create them in Mathematica. You just type in a table function, then you say the first term is what we actually the function in which we input numbers, and then we give a range from which value to which value we are going, and as a result we went from 1 to 5, and it was pasted into this. So first value is 1 squared, 1, and last value is 5 squared, 25. Tables are usually used to create list of values, right? And we will see plenty more examples later. Another thing that we need to cover is what do we do is if we want to take the last output and let's say take a total of it. Total is a function that just gets a total of, let's say, sequence. And the way we get that last output is we press on percent sign. We press on the percent sign, we do shift enter, and as a result it adds up all these numbers. So the whole thing about it is that to get the past output of some sort of function, you just need to press percent sign. This is the main point. And let's say we wanted to plot this sequence, right? Sequence of numbers. How would we do that? We do that with a list plot. We have a list plot, and let's say let's generate that whole function again, and let's say we go from 1 to 10, and as a result we get the list plot. Each value we can hover over it and get 9, which corresponds to 81, 10, which corresponds to 100. What about integration? In order to integrate values in Wolfram Mathematica, all you have to do is to say integrate this function right here. Then you give an expression which you want to integrate. In my case it's sine x over x, and then you give the variable in the relation to which you want to integrate. In my case it's x. If it was y, you would input y. Okay, let's start with a simpler example. That's better. Sine x, and we get negative cosine x. Yeah. Freeform input works in a similar way. You say integral of sine x, and it gives you cosine, negative cosine of x after some time. And another thing is, how do we define matrices in Wolfram Mathematica? In order to define matrices, we say matrix 1 equals to curly braces, and inside of curly braces input another curly braces, then comma another curly braces, comma another curly braces. Then inside of each curly braces you can input values 4, 5, 6, 7, 8, 9, and this is the matrix. This is our matrix which we can 5 seconds. Yeah, this is our matrix, and we can get a determinant from it. To get a determinant, we use this det function, and as a result, we get a determinant of 0. And that's practically it.